So by using signatures, internal, external, we can say if we put in a number, we get back a number.
Yeah, there you go.
Right? Okay, it is November, what is it? It is Saturday, November 19th, 2016. And here we have Oren and Seb going to talk about, what are we talking about today?
Some TypeScript magic.
Yeah, we're gonna talk about some TypeScript magic. One of the more difficult subjects to grasp in TypeScript, I think, is the idea behind function signatures. And function signatures are, they're very common in TypeScript. It doesn't mean you have to use them, but they're definitely being used, and even in these libs that we're used to consuming. So what I wanted to do is actually look at some real-world examples of signatures and how they work, and hopefully, Seb, I can actually get you to understand it. And if you can understand it, then I think other people will understand it too.
Sounds great.
So the thing we'll do is, I worked on some signatures just last night, and if we go look at the source code, there's a bunch of them. And so let's see, I'm trying to think of what's an interesting one that I can review with you. Let's go look at, I think there's going to be some in the array utilities here. Okay, yeah, here we go. This is this is one example of a function signature.
Okay.
The more interesting one I'm looking for is one that actually takes and uses booleans in a very fancy way. But let's look at this one. This one's actually very interesting because it takes. So let's hide some of this code for a minute so we're not so confused, right? And we're gonna go ahead and zoom in here. And so this function is a very simple and very important function. It's in my array kind of comparison lib here, right? And it basically takes two array-like objects, and it will then compare them and see if they're equal, right? Seems pretty straightforward, right? And you can see here, all it is it takes a for loop, it goes through all the different entries, and it uses an equality comparer to say, hey, are these two equal, right? Because depending on if you're using a primitive or if you're using another object, you need to have something that actually does the work of comparison, right?
Yeah.
So it's a very simple thing. And you can specify your own equality comparer, or it will use a default one, which works very well on pretty much the majority of everything, right? So with strict enabled, it'll use a triple equals comparison, basically, is what's going on there, right? Okay, so, and again, no need to go too deep into this and how the function works, but the important part is that this particular function has some signatures added. So this is what we call, if there's only one of them, right, then there's only really one signature, and that means that it's the internal and external signatures are matching, right?
Yeah.
But if you add more signatures, you're going to see that this has two more signatures, okay?
Okay.
The first one omits the strict boolean, right? It's basically saying, yeah, I don't need this for the most part, right? Because strict it'll kind of be the common default, expected default, right? So what we're saying is if you call is equal, or if you call are equal, most of the time you can totally just pass two arrays and you won't need to do it. So for example, let's go ahead and open this up. And now we've got our is equal, or our are equal functions here. And then we have another file that we can use to consume it. Okay. So in here, if we're going to use this, let's say I need to use I'm going to say I want to do a comparison. So I say var a equals, 1, 2, 3, right?
Okay.
So we're creating an array, and we want to do a comparison again. Again, there's no need to understand too much about what's going on here, but we need to have, this is an example. By the way, I've been converting over to using let most of the time. So now we'll let b equal.
Did you set up that check on let?
Actually, that's the default now in WebStorm, is to actually prompt you to change to let. It's almost.
nice.
I did a question on Reddit, and it seems like the majority of people are switching to let now. It's just like the default standard, or it's actually very common, as you're going to see here, to even use the const keyword if you know for sure that the value is not going to change during what you're doing, right?
Yeah, just flag it as constant.
Yeah, if you can put it as a constant, that's the recommended thing, because it shows a more appropriate intention, even in just regular JavaScript, right?
Cool.
And
then if you have you want to have the variables only for that scope, you use let, isn't it?
That's right. Well, like I saw this something the other day, and we could even just kind of do a little quick review of it right now. Is that, let's say, for example, if you had let let's say x equals true, right? If you make an if block and that says
X.
we'll say like
X equal 1.
A 1 equals 1 to be give it a little bit more. Then if you do let x again equals let's say it actually equals something else like a2, right? Completely different value type even. Then there's the interesting thing is that if it was a var, well, actually I think what was the guy said is that if you do this, if it's a var and you go, console log x.
Yeah, you can do that. Yeah, if it's var.
Right? It's totally valid, which is weird, especially coming from other languages, right? So again, using let seems to be the way to go. So let's do another C equals 4, 5. Actually, let's go 3, 4, 5, right? So there's some matching numbers here. Okay. So now, if I want to know if any of these are equal, right? I would say like console log is we'll say are equal. Okay, and then I can actually put the function in here. Interesting. There we go.
There you go.
Yeah. So this function is being imported in right here, as you can see. And the signature that's being routed right now is basically this one here, right? Because it's saying, hey, I'll take an optional parameter of equality compare if you want me to. But all you're doing is passing A and B. And this is the same idea behind an overload in another language like C# or Java, right? Where you can specify multiple ones. Well, it's a similar idea. I take that back, because in those other languages, you have all the capability of having completely different code paths just by redefining the method with different parameters, right? And that's kind of a really cool feature. But this isn't possible in JavaScript. You just can't do it because the names have to be, singular and unique, right? So you can't. This syntax that you see here, these essentially triple the triple expression of the same function is really, again, just a signature. It's basically saying, hey, this is my internal signature. This is what the code expects. These two here are the external signatures. So let me say that again. Internal and then external, right? So the two external signatures are what is instructing outwardly to this code what's possible, right? So let's say, for example, in this case, we'll say, okay, well, what if I want to say I don't want strict comparison? I can put false in there. Now you're leveraging this signature. Instead of, it was this one before, now it's using this one and saying, oh, well, okay, you want to pass that variable in. Now we could do an actual equality comparison, right? So we're going to go ahead and with that, we're going to get, we'll grab it from here. We'll just grab the import directly, and we'll do the same thing that it's doing. So you can kind of see what's going on. And then we've got values. And so I can actually do the full signature. of either one of these to be values dot are equal. Okay, and I pass that in as an equality comparer.
That's cool.
Okay. Now, the hard thing to pick up, keep in mind, and this is more obvious if I put another line here, this is not exposed to the user. The user doesn't know this, or the consumer of the function. Effectively, if I was to, for example, if I was to render or compile this TypeScript code down, and in fact, we can kind of demonstrate that now. Let me go View, Tools, go to Project, and then I'm going to go into my distributions, and we'll just pick anyone, but we'll pick CommonJS. And if I start to drill down and I find the actual type declarations for this, what I'm going to see is that the R equal has two signatures, right?
I see.
This is the type declaration file that gets compiled, right? And so, whereas if you saw what we were looking at, it looks like there's three, right?
Yeah.
But in reality, there's really only two that the consumer knows about, right? It only knows
perfect.
that, yeah. So these are the external, what you see in that file over there. Okay, let me try to get back there. Let's see if I can. Oops. I'm like going back and forth. What we see here is only what the user can do, right? That's what gets rendered out. So, okay, let me go ahead and close my little project window here again. There we go, it's right here. And we'll get back to this one more time. Cool. So now, again, here we have this thing where this is what we were trying to tell the internal code that's available. The internal code expects definitely a set of arrays here. Okay. Oh, sorry, we're on the wrong function. Let me scroll down here. It's this one here. It is the internal code is expecting two arrays to be passed, and that it's going to do a comparison on it, right? And then the strict flag. And what's interesting is this is where it gets a mind bender to kind of wrap your head around. Is this internal signature has to be able to accommodate all of the external ones.
Okay, wait. I'm really curious to see the outcome or the outcome JavaScript code on that.
Oh, on this here.
Yeah.
Oh yeah, no problem. Let's do that. So we're gonna back it up and go down here, and we'll look at the JavaScript here. Okay. This is it here. So what you have to keep in mind is that, and let's in fact.
Perfect. It does the first two lines. It does kind of like a.
Right. Let's go ahead and put this over here, and we'll compare the two to make it simple.
It creates those parameters, presence, if statement, kind of like checkers.
Yes and no.
Okay.
It's not doing any. This is the hard part.
Okay.
Is that the signature? That's why there's this notion of what's an external signature and what's an internal one. The only thing that gets rendered in JavaScript really is the internal one. Right?
Okay.
There's no magic. There's no real magic here. All this is doing is essentially documentation that says this function can do this.
Okay.
Right? It doesn't. There's no way for them to. There's no way for it to magically do all this the shifting around for you, because these signatures can get too complex. Right? Like, one of the more common things you'll see people do is they'll have like parameter callback, right?
Yeah.
But then they'll have another version of that that's like parameter callback, and then they'll have another one called parameter callback.
Yeah.
Right? And that's really hard to implement because you have to detect where the callback function was in the attributes, right?
Yeah.
So again, looking at this, if you look at this as a singular function, it's a function that takes two arrays and potentially an equality comparer, right?
Mm-hmm.
This signature says I take 2 arrays, I potentially take a Boolean flag, and also I might take another equality compare, but in that order, right? You could even per se have the strict parameter at the end here, but this is how this one's set up. We want to have a pretty logical flow. Now, as you can see here, there is 1, 2, 3, 4 parameters, and here 1, 2, 3, 4 parameters matches the internal signature in the actual JavaScript code.
Nice.
Okay, so far so good.
So far so good.
Okay. Now what you are seeing here is that for default parameters, JavaScript will handle that for you. TypeScript will handle your default parameters. So if by chance there is no strict value, it will default to true. That's what this is doing. If there is no equality compare, it will default to the values are equal compare that's provided, right?
Okay.
That's what's happening here, right? That's all that's happening here, though.
Perfect.
Okay. And so then, again, going back to this being the internal signature, which is what the internal code understands, okay? Here's the key. What's actually different between these two, right? The difference between these two fundamentally is that there's an added parameter, and that added parameter just happens to be a Boolean, and it's inserted in the middle of all this.
Okay.
Right? It's kind of inserted there, right? This is kind of like we could say, strict, right? Now, because it's being inserted there, that can create a problem because of the order of which the parameters come in. Basically, what that means is, ultimately speaking, the second parameter that comes in here can be either a Boolean called strict or an equality comparer that's a function.
Yeah.
It can be one of those, or it can be empty, right? So with that in mind, what you have to do is we have to specify here that in the internal signature, we have the strict can be, again, a Boolean, or this is
perfect.
an equality comparison, right? It can be one or the other. And the TypeScript compiler understands that there's this kind of flexibility of types here, that it could be one or the other. Now, a lot of people, when they do in internal signatures, especially in the beginning, because we didn't have union types, this is basically a union type here because it's got this pipe here, right? What we got in the beginning was that you just had to do any on these signatures, right?
No, yeah, and then just like it can be whatever.
And and you'll see that the code's not gonna change on the right at all. It's exactly the same. Fundamentally, that what I just did was exactly the same. It's the same result. The difference is by specifying more strict type assertions here, that if I had a more complex internal function, then I would get this. I will get an assertion that says, if it's a Boolean, then do this, and if it's not, then do that, kind of a thing, right? So that's again, that's kind of the trick here. So you can see here, what I do is to manage the internal signature switching of strict being potentially a true-false value or some equality compare kind of shifting up here, right?
Yeah.
I say, hey, if strict is a function, go ahead and do the shuffling, right? It knows that if strict is a function, you're going to need to go ahead, and that means that you're using this signature, and go ahead and set the equality compare, which is going to pass down in here, to whatever strict is, because strict's a function, and then go ahead and default strict to true, which is what is the default.
Perfect.
Okay.
So the more parameters you have in a signature, the more options or combinations you need to deal with. So there should be kind of like a sweet spot of amount of parameters. Otherwise, better to.
Right. No. And here's the thing, right? Obviously, this is all for convenience for the consumer, right?
Yeah.
There's no in reality, what would I do? I would only have this signature probably. If I could only do one to keep things simple, I would just have this one. with maybe like, a strict being optional, right?
Perfect.
Kind of
Yeah.
thing. But what's going on is that out of convenience, and using this, I'm like, I don't always want to have to worry about passing true or false. What if I just want to skip right to passing my equality compare, and I'll end up adding this added attribute or parameter every time, and that's kind of a pain in the butt, right? So this is just out of convenience. We've added these other signatures, and by adding this, all I really had to do was effectively add this extra code to solve the this signature problem. That doesn't mean that it doesn't. It's kind of like the whole point behind this too is do signatures with or multiple signatures with caution, because it can get out of control, and then you're actually writing extra code to manage the whole thing. So this is one of the reasons why you'll see a lot of functions written with, instead of them being written like this, they might have something more like for example, we'll come over here and we'll show you an example. So like, instead of writing all this crazy function signature stuff, a lot of functions will simply have like, let's say we'll do an equal kind of, another equal thing here.
Yeah.
It'll have a comma b comma options, right? Where options is basically, some sort of like, kind of, key string, and then, like any or something like that, right? So it's basically just a map of values. And, a can be, again, it can be t, it can be t. Okay. And so instead of having this long, insane amount of signature, kind of construction, you just have one signature, but you use an options thing to kind of manage the total variance of possibilities in that function. And that's very common in JavaScript, right? We see that all the time. Yeah. And that's because of why signatures are, again, they're not recommended all the time, but if you see value in them, then you do it. And this is one of those cases. So let me go, how are we doing so far? There's a couple more signature examples I'd like to review.
Yeah, I think it's good.
Okay, so what do you like? So tell me what you think is going on here so far. Give me your breakdown.
Yeah, so for the convenience of the user, it's really smart to being able to present different options on how to use a specific function, especially if you want to allow the user to have or you want to allow the user to use the function in different ways and not have to depend in a completely different function. So
right.
Until now in JavaScript, that was managed like it was always managed in a way that kind of like allowed to it, but not as simple as you can see with the internal external signatures that you wrote.
Exactly. So that's kind of the thing here. So let me ask you the quick quiz then.
Yeah.
How many signatures are actually here that the user can use?
2.
Right. There's this one and there's this one. It's the first 2.
Yeah.
And then this one is the internal signature
that manage the options above.
It's what the internal code is going to see, right? That's
exactly.
The general gist of it. Now, if we got rid of these 2 signatures, then the only signature would be this one.
Exactly.
Right. And it would be the internal and external signature. It's hard for me, even personally, that sometimes I actually have to sit here and write these. I'll probably show you an example of this, where you literally are copying, pasting the internal signature as one of the external, and it's literally just it looks like you're doubling up, but it's
I see.
Yeah, but it's actually important because of how one of the signatures that you have the internal signature matches one of your external ones. Sounds strange, but it will. And then you'll have some other interesting ones that occur on top of that. So we'll try to find an example of that. So I remember one of these cool, let's see here. What if I can do Control-Shift-N, and then we're going to go to Q. Q, I was working on just last night. And I made some changes, and it really kind of made sense with some of these signatures I added. So to kind of break it down, the meat of Q is this try DQ internal. So if you basically add to the queue, then the actual code that does the dequeuing is all here, right?
Oh, cool.
Okay, but here's where it gets really interesting. When you it's important to understand that in with a queue, if you don't use a try DQ, which is the safe method, this is similar to in C#. Try DQ will be safe. It'll say I can't or I can, and it will return a value if it can through an out parameter, right? Now, but with the regular DQ and a regular queue, what will happen is if you don't check and see if there's a count, or if you don't check to see if it has something in it, and you call DQ, normally it's going to throw. Okay. Right? It's going to throw. It's going to be like, hey, dude, you can't DQ this thing, right? Now, what I've done is because of JavaScript's nature and how it works, the default here is to be false. So you can call DQ and you're going to get an undefined value back, right? Okay. And that's, or potentially you could get the actual thing, or you could get an undefined value. And this is the strict null checks in place. We didn't have this option before. What this is telling the compiler is that if you call this method, now let's say, for example, if I didn't have these signatures here, okay, let's just get rid of them for a second. And this is completely fine. You know, this works totally well. But the compiler will basically identify that, oh, if you call this, then I'm not sure whether or not it's going to be the value you expect or one of the values that you expect, or it's going to be undefined.
I see. Yeah.
Okay. And that this default parameter of throw if empty, parameter is kind of saying, by default, I'm not going to do it. I'm not going to warn you in any way. I'm just going to return an undefined value, right? If I set this to true, and we don't have, and we can't DQ it, right? There's something wrong, or essentially the reality of it is that the queue is empty. Then it's going to throw. It'll go ahead and throw an exception for us, right? Which might be, the way we want our code to flow, right? We didn't expect it, so something's wrong. So we want to throw an exception. Well, okay. So here's where it gets really interesting: is signatures can add some interesting value to this. First of all, they can define in a more explicit way. Again, this signature here is effectively kind of useless because it matches, in a way it can match this one if I went like, had like a default parameter, or I could say, hey, I could just have this here and it would do the same thing. But what I'm doing with this code, what I've done, and the reasons for all of these actually has value. So the first thing is that with strict null checks in place, I cannot pass this function. It's not allowed for me to pass anything but a Boolean here or nothing. So remember, this is the internal versus or external, right? So if I pass a Boolean, this is allowed, whether it's true or false. Because it doesn't know if it's true or false, it's going to say, well, it could be the value you want, or I could end up returning null, and if in fact it could actually, there's another type that you can put here that it might actually be that it throws, right? But
what?
Yeah, but this is never is an unnecessary type, if in most cases, because it's kind of like it's an added thing. You can use it never if your function is. It's better to only put never on something that's what it does and that's all it does. It's kind of like a dead end in your code, right? Is a great way to put that type. But what we're saying is, if we get rid of these signatures here, we're saying that DQ, because this is the only external signature now, DQ must take a Boolean. It has to, right? It's saying it has to take a true or false value, and regardless of what true or false value you pass it, it's going to result in the value you want, or it's going to throw, right? Because if you said throw, then true, it's going to be undefined, right?
Yeah.
Now, here's where it gets interesting, though. What if the compiler identifies that you passed it true? Okay. If you were to consume this, in fact, let's go ahead and do our little code check here, where we had that file open here earlier. Let's see, where is that? There we go. Here's our little demo thing here, right? And we'll go ahead and close this and split vertically. And so let's go ahead and import a queue. So we're just going to do like a var queue equals new queue. And we'll go ahead and start it up as like the value A can be the initializer. Oh, sorry, I'm still gotta get over that var stuff, right? Now, what we're saying is that we can sit here and go like let E for like entry or whatever, or is q.dq. All right. And what we're gonna say is we're gonna say by default, we're gonna equal that, right? And what you're seeing here is that if we try to do some fancy stuff where I say function x takes a number.
Okay.
So I'm going to say xa takes a number, or we'll just say like, I'm using a, so I don't want to do that. Let me say, we'll say d takes a number, okay? So we're asserting our types, and it's just a function, and we'll just give it some purpose. All right. Now, if I come down here and I've defined my function, if I say xe, it should work, right? Because we know that we know that when we initialized our queue that we have a set of numbers, and so one of the entries has to be a number, right? Now, and we're just saying, yeah, just give me it, give me that value, I want it.
Yeah.
Right. But the problem is with strict null checks enabled, what you're seeing here is this, that this argument of type number or undefined is not assignable to just type number, because it could introduce a problem. If this function's intention is that it only could handle numbers, right? Like, we'll say for example, +1, right? Or actually even more important, we could say something like, 1 divided by, right? Because if it was undefined, this would go all to hell, right? It would be like nan all over the place, or, so this is protecting us against an accidental undefined value, right? So you're like, well, man, okay, well, what is that? What do I have to do about that? Well, what you can do is you can be lazy and you can actually say, I know it's not going to be undefined. And that's what this syntax is it'll catch up in a sec, but it's basically a way of saying, I'm asserting that by putting an exclamation point in the end, I'm asserting that it's good. You don't have to worry about it. It will be a valid value. It's not going to be null or undefined, okay? And that's
perfect.
But you never want to do that unless you know for absolute certain that that's true, right? Like your code block ahead of it says, I checked the count and then I did it, right? So we're going to put this back. So what's the other way to solve this problem? Well, signatures is the other way to solve this problem. Because now I have a way of saying, hey, it's going to be T or undefined, but I can actually assert that it's T if I tell it to throw. Because it will never return, it's going to throw, or it's going to return an actual value.
Yeah.
Did that click yet? Do you get what's going on here?
Mm-hmm.
So explain it.
So
now, just a reminder: if I remove this if I remove true from here, it'll end up failing out. It'll be like, nope.
Yeah. Well, these true parameter here enforces the type of E. So whenever we use E and X, that parameter is actually a number.
Yes, exactly. Now, obviously, at runtime, you can hack the crap out of all this stuff, and you can cause failures if you wanted to, right? There's you can get around it. But within the compile time environment, we are protected, right? Because what we're saying is that this DQ function, we're trying to be polite to JavaScript people, because in C#, this would throw, period. That would be it. There's no parameters of throw or if empty or not, right? Because it'd be like, oh, kaboom, see you later. You got to handle that, right? You got to put more. You need to put more code up front to handle this. But that's not what I wanted to do. I wanted to give JavaScript people the option to literally check for undefined, right? And go from there. Like, for example, I could demonstrate that if I remove this, and so we already saw that if I change it to no parameter, that it does to your undefined. But I can also put it to false. Oops, sorry. I can put it to false, and I'll get the same result. Because why? Because of this signature.
Oh, I see.
Right? This signature basically says, if it's a Boolean, meaning it could, other than true, right? Then it's going to be, it's going to end up giving an error. Now, again, this is going to take a while to compile it down and figure it out. It's going through some chugging, right? There, see, because I passed false and empty are equivalencies here because of the return result, right? But what if I wanted to allow for this to happen? Well, all I have to do is say, okay, there's a couple things. I can say undefined is allowed, and then this function's going to change, and then it's going to be fine, right? Or simply stated, I could also do even something simpler, and I could say, D is optional, right? That's another part of function signatures, right? And this will compile just fine. It should be like, yeah, sure, okay, you can be, undefined or null, and everybody's happy. In fact, I should be able to just kind of force this to go there, and then I'll speed things up. But that isn't what we really want, right? The whole purpose behind this is we want to make sure that the intention, that when the code is used as it's intended, that you get the intended results. So again, we'll back it up here. And so this has been added, like, for example, in C#, when basically T is a non-nullable value for some reason, then, we know this is the only this would be the only signature. Actually, this would be the only signature in C#. Okay. And that way that when we actually call to these collections and we dequeue from them, then it's going to work just fine, right? We're going to get they're going to get the right type assertions. So yeah, that's another example of signatures and how they're used. And this is kind of an interesting specific one because it's talking specifically about strict null checks and how strict null checks are used. Signatures can get really, really interesting. So, for example, I think there's a couple other instances where I actually look through my code and look for this kind of signature where, hey, if I pass a true value to the function, then the result that comes out of the function will be different than if I didn't, right? Which is really much like how overloads work in other languages and stuff, right? It's very cool because you can change the result coming out and feel like, okay, cool, I don't have to worry. So this is kind of one of these things that if you're a JavaScript user and you do this, then you're like, okay, this is normal to me. I expect it. If I try to dequeue something, I'll get an undefined value, right? But, TypeScript, if you turned on strict null checks, is going to go and say, no, you can't do that, bro. You could cause a problem. And then you're going, oh, well, what are my solutions? Oh, one of my solutions is to just put the Boolean here that says go ahead and throw it if there's a problem, which you don't expect it to happen. But if you do, you're protected, right?
Yeah. That's cool.
Yeah. So let me see if there's I think there's one more that I want to cover that's just a different variation on it, and then I think we're good. And if I go to, just to kind of cover some interesting stuff about signatures as well, because it's not something that is always reviewed. So we're going to go in here to, let's see, disposable, dispose. Okay, let's see. Go ahead and close this and close that. All right. Now, I have this dispose set here. It's basically a bunch of functions that do disposing. But what you're gonna notice here is, and this is the other side of this signature discussion, is to avoid using them as much as possible. Right? I'm gonna go ahead and collapse, and it really is. If you don't have to, for API purposes, it's probably that good not to, right? So we're gonna go ahead and collapse all this stuff here, and then you're gonna see that. Oops, I want to collapse all. Hold on here. Folding, collapse all. There we go. Okay, so you're gonna see if you look through this code, there aren't any multi-signatures in this code.
Okay.
But there could be, right? So one of the things to avoid, for example, is that you have to watch out, like when you have essentially expando attributes, right? Where you can basically be like, yeah, I want to have a set of I want to be able to pass 1, 2, 3 as values instead of passing in an array, right? And actually, we probably should, as a good idea, let's go ahead and look at the actual JavaScript code so that we know what's going on here. Okay. Cool. So if we look at this first dispose method, what we've got is that TypeScript takes these attributes here, and when you specify this syntax, it automatically breaks that out into an array for us, right? It copies it to an array. Now, why do we do that? Well, we do that because the arguments object is not really an array.
Okay.
And there could be some problems with that, right? Like, for example, what if you went ahead and started modifying your attributes collection from your function in the middle of editing? There could be some problems there, right? That's just one example. So normally speaking, it's good practice to make a copy of those attributes and pass them in to another array so you can do array-like stuff on it.
Yes.
And so that's what we're doing here. So now what I'm going to show you is what we've got going on here is I've got this function called dispose, and it takes any number of disposables as parameters. But instead of having like another signature that said, hey, I want to do this, which I could, right? I could totally do that. And then to make that signature work, I'd have to, this is the right way to do that. If I wanted to go any further, I could say, I could have it be a disposable, or, disposable, I could have it be D, and then I could have a disposable item. And then then it would have to be, disposable item or a disposable item array, and that would have to be how this worked. But now imagine how complicated this writing or making this internal signature work will be. It's pretty mind-bending, right? Because you're going to have to come in here and go, oh, well, I need to detect if the first entry is an array, and then then I have to figure out, well, what about if the second entry is an array? It starts to get crazy. So it's better practice, because that's just writing more code for no reason. So it's better practice to try to avoid that. And one of the ways that I avoid doing that is there's an internal function that has a straightforward signature that's all it does, right? You have to pass it an array, and then it's got some other things to manage it, right? So it expects an array, and the other nice thing about it is you have to remember is that when you use this syntax, for example, it's creating a copy, right? It's creating a copy of your parameters and using them, right? So you wouldn't want to, out of safety, create another copy of that array in this function, for example, right? So now I'll show you the other one. We've got a dispose. So this is the externally exposed function that behaves exactly like that signature that I was talking about, where you can pass in an array of these things. So it can take an array of disposable items, and you can see here that's all it is. It's just specifying what that could be. And you can also say, hey, do you want to trap exceptions going through, right? That doesn't matter. The point is that for this external method, right, this exported one, we're saying, check to see if they've passed us anything, see if there's anything in it. If there is, go ahead and make a copy of it, just like this is making a copy, right? And then pass that copy into the actual function that does the work. So why do we do that? Well, we're doing that because if this array was important to the caller, we don't want to make modifications to it. Following me?
Mm-hmm.
So if this function is making modifications to that array,
Yep.
right? Then we don't want to expose the caller to those modifications. So we
No.
always want to kind of make a copy of that array internally to these, right? So,
Yes.
So that's what this is doing. This is just a function that says, hey, go ahead and give me an array of stuff and I'll dispose of it for you. And I'll loop through and get rid of all this stuff. But it makes a copy. And so this internal function is the real workhorse it expects a copy. It doesn't make one for you, right? So
okay, that's a big distinction there.
Right. This one doesn't make like for example, they can kind of put this as this dispose method assumes it's a working copy, a local copy, and is safe for external and is unsafe for external use, right? That's why I have this documented that way.
Yep.
And whereas these, if you go dispose.these, then it says, cool, you're passing me an array of stuff. That's what I expect. And I'm gonna go ahead and get rid of all. If you did pass me something, I'll consume it and get rid of it for you, right? And I'll make a copy of it, and don't worry about your original array that you might be working with for some reason, right? And so then also, again, what is the whole point here behind this whole when we're talking about signatures? It's because if you notice that I could have just had this continuous overload of a single function. But what I did was I actually extended the function to have other functions attached to it. That's an interesting semantic decision that some people might disagree with. But really, I could do anything. Like I could have another function called export function dispose these as well, just the same way. And then I could do, like I said, I could have this kind of thing here, and void, and then I could pass this in, okay, like this. And it's the same. Now notice this is nearly identical, right?
Yeah.
I mean, pretty much they do the same thing. It's just that one signature says, I expect a set of parameters that are each disposables. Whereas this one is, I expect an array of disposables. If I tried to merge these together into one function, this would turn from this many lines of code into probably like 10.
Yeah.
Right? So better to have the user, the consumer, enforce being used a certain type of API that's assertive, than kind of going, well, I'm Mr. Flexible and I want to, cater to everybody. I'm not saying flexibility isn't great. I'm just saying in this particular case, it could bite you, in the long run.
Yeah, makes sense.
Okay, cool. Yeah.
It's good, man.
Okay.
I was not aware of like the kind of like flexibility when makes sense, and for sometimes like just go with simplicity.
Yeah, and that's, again, we didn't really get into union types and stuff, but that's a very common thing, is to use union types to manage a lot of this stuff. Is you can have very complicated signatures that are a single signature, but can take a varying different amounts of different parameters. But at the same time, you could be more constraining, and by adding signatures, it can basically benefit you as well as it can benefit the consumer. Because, for example, you could have a function that you pass a string to that will return a string. Like, in fact, here, let's just do this real quick, because this, I think, is just a last little final touch here. We'll write it right in here. Doesn't matter. Function. We're gonna say do something. Okay. And the internal signature is going to be value, right? But we're going to say that the value can be a number or a string, right?
Mm-hmm.
But what it's going to return is a number or a string, right? And so you don't know what it's going to do inside, right? So, but we need to go ahead and say return. It's going to seem silly, but we're just going to return value.
Yeah.
Okay. So this is all looks fine, right? But what if the reality? But what the thing is that by looking at this, the user doesn't understand, or the consumer doesn't know that if you put in a number, you might get out a string,
Yep.
But that's not true, right? So by using signatures, internal, external, we can say if we put in a number, we get back a number.
Yeah, there you go.
Right? And so this is cool because...
Can you try to use it and see how the IntelliSense kind of like help you out with...
Absolutely, right?
Because at the end of the day, it's like if you don't have IntelliSense, like if you have all this overload, it makes it complicated.
Right. So what we're gonna do is go hello is one. This is the S is for string, right? And let n equals do something, and we're gonna say 8. Okay, just for stuff. And then let's see if it'll actually. It's not gonna tell me until I actually consume it. But let's say we write another function called take string. We'll just say like x string. Okay, and then we're gonna have another function called take number. Right, now remember, if these don't match up, then the compiler is gonna give me some grief. So if I say take string and I pass it in, what we're gonna see, stand by, I think that we'll have to maybe force the compiler to do something here. While we're waiting here, we'll go take number and we'll pass it a string. Yeah, so the compiler is warning me. It's saying, hey, you can't do this, right?
Yeah.
Because it doesn't make sense. But so the IntelliSense, as you say, is figuring out that, hey, you passed it a string, so then this is a string. And you pass it a number, so this is a number, even though this was the same function call. So what you were going to say on line 34?
Yeah, just like delete the last 5 characters, and so we can see the options of do something that you get.
Right. Okay. So let's do. We'll just do another one called let m equal do something.
Yeah.
So now you can see here, it's already showing me I can do number, string, or number or string. Well, cool. I think I thought that went pretty well. This is it's a hard topic to wrap your head around. So it's good to do these deep dives where we kind of review how all that stuff works and get people a little bit more familiar. And it's one of those things that, again, it's not necessary to understand this as a beginner, really. It's not like a absolute must to be able to write your own signatures. But like I've been saying, it's good practice to, for example, if you're a JavaScript familiar person, it's good practice to realize that after you start using types, you realize that too many overloads is a bad idea. Yeah. Right? It starts to really become a problem. So again, this kind of showing that it's possible, but also kind of talking about, hey, maybe you shouldn't. When it comes time, maybe you shouldn't. But you will find pretty consistently, you'll see signatures all over the place in TypeScript. And if you go look at the libs, for example, if we go var a equals new array number. Okay. And if I click on array, it'll take me to the lib. You're going to see, we'll eventually run into some overloads in these functions that are going to be, kind of in there. Like, let's see if it looks like there might be one here. Right. So add event listener as a whole bunch of overloads, for example, as part of this particular class. And what's cool is that these overloads can actually be used literals.
Oh, that's sweet, yeah.
Yeah, really cool. So imagine, just like what we talked about, if you gave it a different string literal, you could say that the return type was something different, just depending on what the actual value of that string was. This is something I've never seen in any other language. Like, it's just not, this is the first time I've seen this. It's very, very cool stuff.